right, you guys, so today we're going to talk about rotations. Our essential question is, how do you rotate a figure in the coordinate plane? So the first thing I want to do is define what a rotation is. And a rotation is a transformation that uses a fixed point to rotate a figure around using a degree of rotation. So I'm going to write the definition. Okay, and then since rotation doesn't change anything about the original figure, this is again a rigid transformation. So recall, rigid means that it preserves all angles and side measures. So the original or the pre-image and the image will be congruent. They'll be the exact same thing. Okay, this fixed point that we rotate an image around is called the center of rotation. Okay. And then last but not least, we need to know exactly how far we're rotating an object. So that is called the angle of rotation. The angle of rotation is how far around the center of rotation we rotate the original figure. All right, I know, 3 big vocab words there. But I also want to make a really quick note that the angle of rotation pretty consistently refers to a counterclockwise rotation. The only instance in which it would be clockwise is if the diagram says rotate clockwise. Every other time we're going to assume that you're rotating counterclockwise. So out of necessity, always rotate counterclockwise. So I'm going to write that here. Rotate counterclockwise. Okay, and for those of you who are maybe having some trouble with the counterclockwise, if this is the center of rotation, you're rotating to the left and around. Okay, counterclockwise. So here's my original image, a little square. That's how you're rotating it around that image. Okay. Okay, so I've drawn a little pseudo diagram in the coordinate plane. So if pre-image A is in quadrant 1, this is Q1, then when we're rotating, when you rotate around the origin in a coordinate plane, you can rotate 3 or more degree measures. So the first rotation that you could create is a 90-degree rotation. 90 degrees, which will end your coordinate A prime in the second quadrant. Okay, you could also have rotated A 180 degrees. Okay, and again, we're still going counterclockwise, so we go 180 degrees this time. Here's A double prime. You could also rotate coordinate A 270 degrees. End up somewhere around here. Okay, if you rotate A 360 degrees, then guess what? Your A and your A prime will be the exact same measure. So I'm going to make a note that you can rotate 360, but that maps the image directly onto the pre-image. And it maps onto the original. Okay. You can also rotate more than 360 degrees, but the result will be the exact same as if you rotated that number minus 360. So for example, if you rotated 450 degrees, rotate, that's the exact same as rotating 90 degrees, because 450 minus 360 is 90 degrees. And so you would get the exact same image as you would if you just rotated 90 degrees. Okay. When you're in the coordinate plane, we use 90-degree angles because our coordinate plane is broken into 90-degree sections. So I've got a 90-degree section here, one here, one here, and one here. Okay. However, you can rotate a smaller amount than 180, a smaller amount than 90, a smaller amount than 270, etc. It's just when we're in the coordinate plane, we don't do that because of the way that the coordinate plane is set up. So it is possible, but for right now, because we're just doing an introduction, we are not going to deal with that. Okay. All right. So then I'm going to do coordinate rules next.